today's class. So today we will learn the chapter 6, section 3, conversion factors. Conversion factor, it's try to help you convert a quantity from one unit to another unit. Suppose I give you a 1 feet and then ask you how many inches in 1 feet. Then you know that's equals 12 inches, right? So then we can write this conversion factor as 1 feet divided by 12 inches. This one equals 1, right? Now let's see. We can practice this problem. Okay, 1 feet is 12 inches. How many feet are in 64 inches? Okay, everybody, you can send me your answer in private chat. Now let me check. "64 inches. That's equals how many feet? Okay, Lucy got an answer. That's oh, Brandon, how you got a 768? That's not times. See, feet is smaller. So if you want to convert an inch is smaller. Convert inch, 64 inch to this one's inch to feet. You need to do this one, that's 1 feet equals 12 inch. You need to do this multiplication, right? So this inch comes out with inch. Then 64 divided by 12, that's equals 5. The remainder is 4, right? 4 over 12. Then you simplify this one, you get 5 and 1/3 feet, right? You can also write this one, it's 16 over 3 feet. Okay. Yeah, you can also write that's decimal 3.33. Okay. But then they did not ask you approximate. So if you write a decimal, you need to write like this, 5.3. Then you add a bar above this 3. So that means this 3 keep repeating. Okay, this is A. Now let's see B. See, there are approximately 454 grams in a pound. How many grams in 0.35 pound? Everybody do this. They ask you round your answer to the nearest gram.
I have a quick question.
Sure.
What page is it on?
What pages? I need to check.
Okay.
Let's see. That one will be chapter. Okay, that's page 167.
Thank you.
Page 167. Okay. Now let's do this problem. Everybody do this. They ask you how many grams in 0.35 pounds. 0.35 pounds. Suppose I use PDS to replace pounds. In each pound, you have 454 grams. So let's use G RAMS to represent grams. Then over each pound. So that's just use 0.35 times 454. Then they ask you round to the nearest gram. So do it, then send me your answer. So 454 times 0.35. Everybody do it? Brandon, what's your answer?
I didn't get it yet.
So you use 454 times 0.35. This one, you got about 159 grams. Okay, that's B. Okay, now let's go to next one. So this is 159. Now let's see 6.9. 6.9, say this problem, say there are approximately 3.28 feet in a meter. In this problem, we'll determine to the nearest square feet. How many square feet are there in 28 square meters? Okay, so here we try to convert square meters to square feet. So first, you need to create a conversion factor between the feet and the meters. So to write that one, you just write this. Say one, if you try to convert to meters to feet, you can write it this way. You can write, let's see, you can write 3.28 feet, this one feet, over 1 meter, right? This one equals 1, right? By this way, you can convert the meters to feet. Now let's see. We can write 28 square meters and 28 meter square. So we can write this one, 28 meter square. This one we can write, this one's 28. So meter times meter. Okay. Then each meter, you use this conversion factor. You can write this one's 28. Then each meter, you can write 3.28 feet over the meter. Then here you times meter. By this way, we convert this meter to feet. Then another meter, you do the same thing. 3.28 feet over the meter. So then you can see the meter comes out, meter. So you got a 3.28 feet times 3.28. So that's 28 times 3.28 square. Then this one will be square feet. Okay. Then you do this multiplication. 28 times 3.28 square. So this one, what do you get? Everybody do this. See what you get. This one, you will get 28, 3.28 squared. This one equals 10.76 square feet, right? Then 28 times 10.76, you get about roughly 301 square feet. Okay, FT squared. So I use F. You can use FT. Okay, FT. That's represent feet. So the answer for this one, that's equals 301 square feet. Okay, nearly get the correct answer. Very good. Okay, may get the correct for the previous problem. Okay, this is 6.9, right? Now let's see 6.10. See this one, they ask you, say, Dr. Khan has ordered special medicine from Europe. It comes with a strict instruction to use 32 milliliters per kilogram that the patient weight. However, all of the Dr. Khan's scale only tell weight in pounds. So he wants to know how many milliliters per pound he should use. There are approximately 0.4536 kilograms in a pound. Okay, so first ask you write a conversion factor that related kilograms to pound. So think first, you try to find the milliliters per pound. So that means you want to convert the kilograms to pound. Kilograms to pound, so then that means you can do this way. Pound, each pound, 1 pound over 0.4536 kilograms. This one will equals 1. This ratio equals 1, right? So this is a conversion factor between pounds and kilograms. Now let's see. We can write 32 milliliters per kilograms as this. Then you convert this one to pounds. So you just times 1. Say this. So if you write this way, you want to convert to pounds. That means we need to flip this. We need to write 0.4536 kilograms over 1 pound. Over 1 pound, this one equals 1. Okay, so write which one on the top, which one on the bottom, depend on what you want to convert. So because if you write this one per kilogram, that kilogram on the denominator position. So if we want to convert to pounds, so that means you need also put the kilogram to the numerator, the pounds on the denominator. So that means we need to use this one, this conversion factor. So we can write this one here. It's 0.4536 kilogram over 1 pound, right? So then you use 32 times 0.4536. See what you get. Then I will do this multiplication. Then let's see, this one, it's roughly equals 14.5 milliliters. Then that's units based on per pound. That would be the correct answer, right? Because see, this kilograms on the denominator. So if you want to convert to the pound, you also need to put the kilogram on the numerator. Then this kilogram will cancel out. Then you have pounds at the denominator, right? So this is what you need to do. Now let's see. 6.11. So this one, they ask you to say, my boss has told me that I will need 1 gallon of paint for 1 gallon of paint. 1 for every 300 square feet of wall. Unfortunately, the store only sells cans. Cans contain 4 liters of paint. And our client that has told me that she needs 370 square meter. This 1 square meter of walls, a wall painted. 1 liter contains approximately 0.64 gallons. And there are approximately 3.28 feet in a meter. In this problem, we'll find the smallest number of cans of paint I can buy to complete the paint job. Okay? See, this problem is a little bit complicated. You need to read this problem carefully. Now, you need to know, they ask you to find the number of cans. To do that, you need to continue convert. First, let's say, they give you the walls in square meter. So first, you need to convert the square meter to square feet. Then, based on this ratio, each gallon of paint can paint 300 square feet. So you use the number of square feet of the wall divided by 300 feet, then give you number of gallons of paint you need. Then each gallon of paint, each gallon that have you can convert to liter, because 1 liter equals 0.264 gallon. So you use your result divided by 0.264 gallon, then you got the number of liter. Then 4 liter, that's equals 1 can, right? So they tell you cans contain 4 liters of paint. So after you got the number of liters, then times, then divided by 4. That'll give you number of cans, right? So then we can do this way. 370, this is in square meters. Because each meter equals 3.28 feet. So then we convert this one to square feet. We do 370 times 3.28 square. By this way, we get the square feet of the wall. Then you divide by 300 square feet. This gives you the number of gallon. Number of gallon, then number of gallon, because each liter equals 0.264 gallon. So this number of gallon divided by 0.264 will give you the number of liters. Number of liters, because 4 letters that give you 1 can. So then you divide this, your result by 4 again. This will give you the number of, this result will give you number of cans. So you just need to do this operation. 370 times 3.28 square. This one, that's a wall in square feet. Divided by 300 square feet give you number of gallons of paint you need. And each gallon, you know, each gallon with the relationship, that should be 1 over 0.264, because each letter contains 0.264 gallons. So you use number of gallons you get divided by 0.264, then you got the number of letters. Because 4 letters, that's 1 can. So you divide it by 4, they give you number of cans. By this way, we can get this number. Everybody do this. Now let's check. If you got a result, send me your answer. Now let's see. First, you 370 times 3.28 square. This one give you then this one divided by 300 give you about 13.3 gallons. Then 13.3 divided by 0.264, this one will give you, let's say, 50.4 letters. 64, this is the letters. These letters divided by 4 will give you about 12.6 cans. Okay, so the answer for this problem is about 12.6 gallons, not gallon, cans. Okay, now let's see problem 2.12. See this problem. See, on plant gulp, 2 gibs are worth 3 gibs. 2 gibs are worth 5 gulps, and 3 gulps are worth 2 gulps. How many gulps are 7 gibs worth? So this kind of problem, just do this way. Say 2, I use this one, use G, E to represent this gibs. Worth, this worth 3. I use GI to represent this letter. And they say 2 GI, this GI worth 5. I use GO to represent this gulps. Then say 3 GO worth 2 GU, right? Now they ask you how many GU are 7 GE, is 7 GE worth. Okay, now let's see. 7 GE. Okay, 7 GE, they ask you equals how many GU. So we can first convert this one to number of GE to number of GI. Then by this ratio, 2, 3, right? Then use the next ratio 2, GI equals 5 GO. We can convert number of GI to GO. Then use the next ratio GO to GU. We can get the number of GU, right? So then we can do this way. 7 GE equals 7. Then say GE here, you need to put the GE to the denominator position. That's 3GI. 3GI equals 2GE. Do this way, right? Now, after that, then you got a GI. Then, okay, GI to GO. So you write GO, this is 5 to 2GI. Then 2GU to 3GO, right? Then you simplify this, you got to say, this 2 cancel out. Now let's see, this 3 and this 3 cancel out. So that would be 35 divided by 2, right? 17.5 GU, right? That's 17.5. Notice how you got a 14.5. 17 point.
Probably made a mistake somewhere.
Yeah, double check. You made a mistake somewhere. Lily got it correct. 17.5. Now let's see others. May got it correct. 17.5. Okay, very good. So this problem is a little bit hard, but if you do it this way, actually it's not hard. You just connect the information carefully, then write down that ratio, do this step by step, then you should get a correct answer. Okay, now we finished this section. This exercise problem from 6.3.1 to 6.3.6, that will be your homework, okay? So now let's go to this section 6.4. This is a percent. Percent actually is very easy. Percent it's a ratio, but with the denominator is 100. Okay, say 25%. Okay, usually we write percent is like this, 25%. 25%, this one just equals 25 divided by 100. It just means this. Okay, then you can simplify this. So you got a 1/4. So 25%, actually that's equals 1/4, right? So if you try to calculate, let's say 25%, like 50% of 8. So that's 1/2 of 8. So then that will be 4, right? So now let's see some exercise. Let's see this one, 6.13. So this one, they ask you find the number that's 60% of 250. Say this one, that's very easy. 60%, 50% of 250, that's 125, right? So that's just use this percent times, you just use this percent times this number. So you use 250 times 60%. So this one, you need to simplify 250. 60%, that's 60 over 100. That's 6/10, right? So this 10 cancel out. You got a 25 times 6. So that's 150. So that means 60% of 250, that's equals 150. So here, if you use algebra way to do this, you can write a ratio. Say, suppose that number is x. Then x is 60% of 250. So that means we can get x over 250 will equal 60%. So you can get this. X over 250 equals 60%. Then you solve this equation. You get x. Say x equals 250 times 60%. This one equals 150, right? You can also do this way. Now let's go to 14. This one, say we try to determine what percent of 240 is 48. So to do this, you can suppose 48 is x percent of 240. Write the equation. So you do 240 times x percent. This one give you 48, right? So cancel out 1 0, then both sides times 10. You get 24 times x equals 480. Then x equals both sides divided by 24, you got 20, right? So that means 20% of 240, that's equals 48, right? Say you set x, then you solve x, you get x equals 20. So that's means 20%. Okay. Now let's see 6.15. This one, they ask you 36 is 120% of what number? Okay, you can set that number as x, right? Then you can immediately write the equation. That's 36 equals 120% times this x, right? Then you simplify 120% actually equals 12 divided by 10. X, then this one equals 36. So both sides times 10, you got 360 equals 12 times x. So then both sides divided by 12, you got x equals 30, right? So that means 30, 120% of 30 equals 36. So actually 30 times 1.2 equals 36. That's right. Now let's see. Let's see problem 6.16. Let's see this one. Let's see this. See, when we increase a number by some percent, when we increase a number by some percent, okay? When we increase some number by percent, we add that percent of the number to the number itself. For example, when we increase 24 by 75%, we add to 24 the number that is 75% of 24. Say A. When we increase 24 by 75%, what number do we get? Say, everybody do this. Say, you add 75% of 24 to 24. So you need to do 24 times 75%. Say, first you need to calculate what is this number. This one, you simplify, this is 3, this is 4. So this one equals 18, right? So that means you need to add 18 to 24. So you got a 42. Okay, very good. Lucy got it correct. Oh yeah, Lucy, that's correct. You also can times 175%. That's correct. You can also do that way. But here we just try to explain this problem. You can use 24 times 175%. That's correct. Now let's see. When we decrease 60 by 40%, what number do we get? Decrease 40%. So first you need to calculate what is 40% of 60. By this way, we get this one equals 24, right? So then 60 minus 24, we got a 36. Okay, make it correct. 36. Then this is one way. Okay, you can also use 60 times 60%, right? Decrease 40%. So that means that new number, it's only 60% of the old number, right? Old number, that's 60. You use 60 times 60%. Yes. Now, say C, they ask you find the expression for the number that result when we increase x by k%, and the expression for the number that result when we decrease x by k%. So the new number, if x you increase by k%, the new number will be x plus x times this k%, right? So then we have a common factor, that's x. We can take this x out, that's 1 plus k%, right? So you can also write this one equals x, then 100 plus k, right? Then divided by 100, right? You can also write like this way. And decrease k%, that new number will x minus x times k%. So you can take common factor x out. So that's 1 minus k%. So you got the x times 100 minus k, then divided by 100. You can also write that this way. Okay, say this is a general formula. If you increase a number by k%, how to calculate that new number. Also, if you decrease a number by k%, how you calculate that number. You can use this formula. But if you already understand, actually, you don't need to memorize this formula. Okay, this is, we already finished this one. Now, okay, 6.4.1 to 6.5, that's your homework. Okay, now let's go to 6.5. In this section, we'll learn the, let's see, what do we learn? We will learn the percent. We need to learn this percent problems. So that's word problems. Let's see first one, 6.17. This one said, I need to make $450 per week after tax in order to pay all my bills. The income tax rate is 25%. What is the smallest pre-tax weekly salary I can earn and still be able to pay my bills after I pay my income tax? Okay, everybody do this on your scratch paper, then send me your answer. How much you need to earn before pre-tax, then we'll give you the after-tax $450. So the tax rate is 25%. So they ask you the pre-tax, you can set that number is X, right? So X times 75%. This one will give you $450. So then you can simplify this one. You got that 3x over 4 will equals 450. So both sides you have common factor 3. Let's cancel out this one. You got 150. X over 4 equals 150. So both sides times 4, you got x equals 600. Right? So that's 600. Okay, Lily got it correct. Now Lucy also got it correct. Very good. Now let's see 18. 18, say this problem, say on Monday, Sammy, the storekeeper, decide to increase the price of our avocado by 20%. Okay, raise the price by 20%. On Tuesday, he increased this price by another 25%. Then they ask you, A, what percent of the original avocado price is the price of avocado after both increase? Okay, everybody do this, then send me your answer. On Monday, increased 20%. On Tuesday, then raise on the price after the Monday, another 25%. Then they ask you what is percent of the new price compare what percent of the original avocado's price is the price of the avocado after both increase? Jasmine, your answer is wrong. How are you going to do 45%?
I just added them together.
No, if you do that way, that's wrong. Let's say Lily and May, I think, get it correct. This not exactly just add these two numbers together. You can should do it this way. So to solve this kind of problem, usually give the original price as 100. That would be the easiest way. Okay, let's set the original or our avocado's price is 100. Then after the first 20% increase of price, the new price will be 120, right? Then add another 20%, that 25%, that's based on 120. So you need to calculate 120, 25% of 120. So then this one times 25%. 25%, that's 1 over 4. So this one equals 30. So that means add 30 to 120. So then after 25% increase of 120, then you got the 150, right? So then that means the 150 over 100. So that's 150% of the original avocado price is the price of avocado after both increase. So that's 150%. Okay, so May and Lily both got this one correct. Okay, now let's see B. Say on Wednesday, Sammy decided to return the avocado to their original price, by what percent must he decrease the Tuesday price? The Tuesday price is 150, right? It's 150. So return to original price. Original price is 100. So that means he need to decrease 50. Okay, percent, that would be 50 over 150. So this one will equals 1/3. 1/3, if you convert this one to percent, that would be 33.3. Keep repeat, right? They will be like this. 33.3. Keep repeat. Okay, Lily got a correct answer. Very good. See, when you increase a number by percent, say you increase 100 to 150, you increase 50%, right? Say, I mean from 100 to 150, right? So if we calculate the percentage increase, that would be 150 minus 100, then divided by 100. This way give you 50%, right? If you increase 100 to 150, you increased 50%. But if you decrease from 150 to 100, that's not decrease 50%. That's actually you decrease 150 minus 100, then divided by 150. That's give you 33.3%, right? If you decrease 50%, the number what you get will be what number? Lucy, if you decrease 150, 50%.
Wait, 150 by what?
By 50%.
You would get 75.
Yes, then you got a 75. You not got a 100. So here, I just want you to understand, if you increase, you need to increase the more percent than when you decrease, right? Say, you start from 100, increase to 150. You need to increase 50%. Because here, you use 100 as the denominator. But when you decrease from 150 to 100. Because you use 150 as denominator. You only need to decrease 33.3%. Then you got the same number. 100, return to the same number. Okay. Now let's go to 19. This one says, suppose that 66% of the 8th grader and 3%, this is an 8th grader, 3% of 7th grader at Washington Junior High participated in math counts. There are 1.5 times as many 8th graders as 7th graders at the school. What percent, they ask you what percent of 7th and 8th grader take together participate in math counts. Okay, now let's use E to represent number of students in the 8th graders. Let's use S to represent number of students 7th grader in this school. Then you can say here, say what does they ask you? They ask you what is the percent of the 7th and 8th grader participated in the mass counts. So 6% of 8th grader. So you use 6% times E, right? Then plus 3% of S times S. This gives you the total number of 7th and 8th students participating in the mass counts, right? Then if you divide it by E plus S, E plus S give you the total number of the 7th and 8th grade students. Now let's see. Here, they tell you 8th graders, it's 1.5 times of 7th graders. So that means E equals 1.5 times S, right? So we can plug 1.5S to replace E in this expression. We can get, say, 6% times 1.5S, then plus 3% times S over 1.5S plus S. Because we have S everywhere, so then you can just cancel out this S. So this one will be 6% times 1.5. So, you know, later we still try to get a percent. So let's times 100 to the numerator and the denominator. So then the numerator will be 6 times 1.5 plus 3 times 1, right? 3 times 1, that's 3. Then the denominator, that's 1.5 plus 1, that's 2.5. 2.5 times 100, right? So then now let's calculate this, simplify this. 6 times 1.5, that's 9, right? 9 plus 3 over 2.5 times 100, that's 250. So then this one, 9 plus 3, that's 12. 12 over 250. So we can simplify this one's 6, this one 125. 6 over 125, when you still can continue simplify by 3, right? This one will be 2, this one will be 4. No, this one, we cannot simplify this anymore. So that's 6 over 125. Now, but we need to convert this one to percent. So that means we need to do this division. 0, then put another one, that will be 4, that will be 500. So 100, there will be 8. So that will be 4.8%, right? So got that percent will equals 4.8%. This is one way. This is a normal way to do this. Actually, you have the shortcut. Simplest way. Let me ask Lily, can you tell me, do you have any easier way to solve this problem?
I don't know.
Okay, May. So I suggest every time when you try to solve this kind of problem, you give a simple number. Now let's see here. 7th grade, it's 8th grader, it's 1.5 times of 7th grade. We don't know 7th grade students, right? Now let's say that's 100 students. Suppose 7th grade, that's 100 students. Then 8th grade will have 150 students, right? Because 8th grade students, it's 1.5 times of 7th grade. Then we suppose 7th grader is 100 students. Then 8th grade will have 150. So then the total number of 7th and 8th grade student will be 250. Now let's count how many of 7th and 8th students participate in the math count. So 8th grade, 6% of 150. So this gives us 9, right? 6%, 1.5 times 6, that's 9. 100 of 3% of 100, that's 3. So we got 12 over 250. See? Then you simplify this one, 6 over 125. Then you do that division, you get 0.8%. Right? Very easy, right? If you don't do this way, say what I just show you normal way, you need to set a variable. You need to set number of 8th grade is E, number of 7th grade is S, then use that relationship. Then later you need to cancel out the 7th grader, then you do that. Actually, so for this percentage ratio, right? You just give them a number, a simple number, makes the problem easier because you don't really care about the absolute number. You just care about the ratio. So do this way, that will be much easier. Now let's see 20. See this one, you have 100 milliliter of solution. That's 20% of acid. Then they ask you how many milliliter of solution must be replaced with pure acid in order to have a solution that's 30% of acid. Everybody do this on your spreadsheet paper. Give you 2 minutes. Now let's say this one. They ask you how many milliliter of solution must be replaced. Let's suppose that's X milliliter. After that one be replaced, so the left solution will be 180 minus X. This one, after you replaced, the original solution will be 180 minus this X, right? This after you replace X milliliter of solution. But then you replace this one, use a pure acid, okay? So that means 180 minus X. This one, it's 20%. Then you plus X. Pure acid, that's 100% of acid. This one gives you 180 times 30%. So that means you need to solve this equation, right? See, this is X milliliter of solution you need to replace. So the left original solution will be 180 minus X. Then you times 20% because original solution is 20% acid. Then you plus X, that's the pure acid you add to the solution. Then in this new solution, the rate is 30%. Amount that's still 180. So then to solve this equation, both sides times 100. So you get the first one that's 20 times 180 minus X. Then plus 100 times X. That equals 180 times 30, right? So then both sides you can divide by 10. You get the first one that 2 times 180 minus X. Then plus 10X. This one will equals 180 times 3. That's 540. So also can both divide by 2. This 5. This will be 270. So then we just add merge the like terms, 5x minus x, 4x. Then 270 minus 180, you get a 90. So get a x equals 4, let's say 245. So 22.5. So that means you need to replace this amount of original solution, then you can get that. So then time is almost up. We already finished this section. So your homework, you also need to finish this exercise behind this section. Now let's see. That will be from 6.5.1 to 6.5.7. Okay, so we can stop here. So actually, we already finished this chapter, right? So then that's summary. This chapter, we learned the ratios, percentage. You also need to finish the homework for all the review problems. Then problem next time, we can review some problems, and then we can go to the next chapter, chapter 7. So we can stop here. Everybody, bye.
Bye. Thank
Bye.
you.
Thank you, bye.